Okay, let's look at our exponent rules. Recall that an exponent represents a shorthand notation for multiplication, right? The big number is called the base and the smaller number is the exponent. So if I had a number like this, the 3 is the base and the 4 is the exponent. And the exponent tells us how many times to multiply the base times itself. So this is the same thing as 3 times 3 times 3 times 3. 3 multiplied times itself 4 times, which then would say, okay, so then that's 9 times 9 is one way we can figure out that that's 81. Now remember, the exponent only applies to the one thing it is sitting on. So for example, in 5x squared, the exponent is only applied to the x. Otherwise, if we wanted the whole 5x to be squared, it would need to be written like this. Now that would mean the 5 and the x are being squared, so that would be 25x squared. Here's some other examples to be very careful of. Negative 5 squared means that square applies only to the 5. So this is negative 5 times 5, or negative 25. If I wanted the whole negative 5 to be squared, I would need to write it like this, right? Then, if it's on parentheses, it means everything in the parentheses gets multiplied times itself, so you'd have negative 5 times negative 5, which would then be positive 25. So on the next slide, we're going to have some rules that allow us to simplify some exponential expressions. Okay, to be considered completely simplified, and just like radicals and just like fractions, it goes without saying that our exponential expressions have to be simplified. And to be completely simplified, we don't want any numerals that can be combined or simplified, right? No math we can do on the numerals. You only want one of each variable, no parentheses, no negative exponents, negative or zero exponents either. So remember, these rules do not apply if the expression involves any plus or minus signs. Just like always, look out for those plus or minus signs. Everything has to be only multiply and divide. Okay, so here's a list of rules. So this might be a good slide for you to print out. Okay, so if you are multiplying, if you are multiplying two exponential numbers that have the same base, right? The big number is called the base. You add the exponents together, right? Think about what this means. If you had an x cubed, that's x cubed, right? And if you want to multiply it by 2 more x's, oh, then all of a sudden you have 1, 2, 3, 4, 5 x's being multiplied together. So you can just add those exponents. If you're dividing two exponential numbers with the same base, got to have the same base, you can subtract the exponent. So let's think about what this means. That means x to the 5th looks like this, right? That's what that exponent means, 1, 2, 3, 4, 5. And then if you had an x cubed on the bottom, oh, because there's no plus or minus signs, anything that's the same on the top and bottom gets to divide out, and you're left with just 2 x's because 3 of them divide out. If you have an exponential number raised to another exponent, you multiply the exponents. Okay, let's think about what this means. Inside parentheses first, you'd have, that's x cubed. And then if you want to square it, well, that means multiply that times itself, and you'd wind up with 6 x's all multiplied together. Okay, so anytime you have an exponent on parentheses, it goes to everything in there, right? As long as it's multiply and divide. Not with a plus, not with a plus, right? This is not a to the n plus b to the n. Look out for those plus or minus signs. Only when it's multiply. Then you can just put it on everything in there. Okay, this is basically the same thing. It's saying if you have an exponent, on parentheses, and as long as it's multiply or divide, you just put the exponent on everything inside the parentheses. Negative exponents have nothing to do with negative numbers. I'm going to say that 20 times. Negative exponents have nothing to do with negative numbers. Negative exponents have nothing to do with negative numbers. Negative exponents mean reciprocals. Okay, so if you have a negative exponent, the way you make it positive is you change its place in the fraction. And if you can't tell where the fraction is, we can always put it over 1. So you move it to the denominator if it started out in the numerator, or if it started out in the denominator, you move it to the numerator. That is because it makes no sense to have a negative exponent. Remember what an exponent means. It's telling you how many times you multiply this x by itself. And you can't do something a negative number of times. You can't walk -3 miles. You can't paint -3 rooms. You can't multiply -3 times. You can't do it. Where a negative exponent comes from is it means somewhere along the way you did a division where the bigger number was on the bottom. So if you had an x squared divided by an x to the 5th, and when you cancel out the x's, you've got x's in the denominator. But if we followed our rule up here, if we followed this rule, that would say we had x squared over x to the 5th is x to the 2 minus 5, or x cubed hold on, guys. Get out here. Okay, sorry about that, guys. I don't want to do this whole video again, but I've got a little nest of baby rabbits in my yard, and a crow came up earlier and took one and killed it, and so it keeps coming back to trying to get the others. I'm trying to shoo it off. I mean, they're tiny rabbits. Okay, sorry. Okay, back to where we were. Okay, so you'd have x to the -3. Okay, this is the same problem, so this has to be the same answer, 1 over x cubed. I just need to remember that negative exponents mean reciprocals. Negative exponents have nothing to do with negative numbers. Okay, so if you have a negative exponent on parentheses, that means that negative exponent goes to everything, and everything's going to change places, right? Otherwise, only the one thing it's sitting on. A zero exponent is basically from the same thing. It means you divided something by itself. Okay, if I followed my rule, I'd get a zero exponent. But if I look at this, anything divided by itself equals 1. So a zero exponent equals 1. Anything to a zero exponent equals 1. Negative exponents mean reciprocals. Nothing to do with negative numbers. So let's look at some examples. Okay, now these exponents are not sitting on the parentheses. They are inside. This one doesn't have an exponent. And that's just a multiplication. I don't even really need those parentheses, right? Because that's what this means, is multiply, or this means multiply. Okay, no exponent. Anything to a zero power is 1. And then this just means 2 times 2. So 2 times 1 is 2, times 4 is 8. Okay, now this I could go 6 times 6 times 6 times 6 times 6 times 6 times 6. Oh, but I don't want to do that. Instead, I want to recognize, hey, if I use my rule, think about what this means. Let's think about it one time. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And on the bottom, I've got 1, 2, 3, 4, 5. So all of these would get to divide out, and I'm left with a 6 squared. Right? 7 minus 5 is 2. 5 of them are going to get to cancel. And then this I can do, 6 times 6. Negative exponents mean reciprocals. Negative exponents mean reciprocals. So if I make these look like fractions, only the one with the negative exponent moves. This one does not have a negative exponent. Don't move it. So it's going to stay in the numerator. This one has a negative exponent. Now, I could think the same thing. Let's think about what that means. Right? And so one of them get to cancel. So you have 1 over 3 times 3. Okay? So, hey, if one of them gets to cancel, I'm left with 2 3's in the denominator. Here, when I cancel 5, since most of them in the numerator, the ones that are left are going to be in the numerator. Here, most of them are in the denominator, so when you cancel this one, you're going to have 2 of them in the denominator. Okay, an exponent raised to an exponent means you multiply. So 3 times 4 is 12. 2 times 7 is 14. Now, I've got more in the denominator, so I know they're going to be left in the denominator. I just have to figure out how many. Oh, if there's 12 in the numerator and 14 in the denominator, 2 is going to be left in the denominator. And that means everything canceled up top, right? So there's always a 1, always a 1. Don't leave that blank or think it's 0, right? It's a 1. All right, a couple more. And look, these look like, oh my word, they're getting massively confusing. Just work one piece at a time. And typically, and it doesn't matter which ones you do first, which rule you apply, but I'm always going to simplify my numbers because I want to make them smaller before I make them bigger. So simplify any numbers if you can and get rid of negative exponents. Okay, other than that, it really doesn't matter. So look right here, I've got 16 and a negative 4. So I know that's going to divide out and leave negative 4, right? 16 divided by 4. And if there's one negative sign, it's going to be negative. So that's my first step. And I'm going to just write it all so that, just for emphasis, right? I could have gone ahead and worked on my others and done it in one step. Okay, so numbers first. I don't have negative exponents, but I do notice that, hey, I've got x's that's the same and y's that's the same. I can't leave that. I can simplify that. There's 2 x's in the top and 5 x's in the bottom. Now, I'm done with that number. That means I'm going to have some x's left in the bottom when these simplify. How many? Well, 2 of them is going to get to cancel out. That means there will be 3 left in the bottom. And if I didn't already have a number up here, I'd have to put a 1, right? Just a placeholder 1. But I already have a number up there. Okay, so now I have y's. There's more y's in the top than the bottom, so I know there's going to be some y's left in the top. How many are going to be left? Well, if there's 4 up here and 3 down there, 3 of them are going to cancel out. So that's going to leave 1. And if it's a 1, we don't have to write that as our exponent, right? When an exponent is not written, it's understood to be a 1. Just like when a number is not written in front of a variable, it's understood to be a 1. Okay, so when I look at this, I see, ooh, I've got parentheses in these parentheses. So I need to do those parentheses, and I've got negative exponents. All right, so I'm going to just go straight across and get rid of these parentheses in here. If I have an exponent sitting on parentheses, it means it goes to everything in the parentheses, as long as it's not adding or subtracting, everything. So because this is a 1, 1 times 3 is 3. This is a 2, 3 times 2 is 6. I just have to memorize that rule, really. Okay, that has a negative exponent. That means it needs to change places to become positive, right? So now I've taken care of, I've got my W, my X, my Y, my Z. Everything in the top's been taken care of. Okay, let's move to the bottom. That's fine. Uh-oh, negative exponent. So to make it positive, it needs to move. And I'm just going to write that for emphasis, but we really wouldn't write it. Okay, that's fine. And the Z is fine. Again, for emphasis. Okay, now I'm working inside the parentheses, just like here. I got rid of these parentheses. I'm working inside the parentheses. Okay, I don't have any numbers, but I got a W up here and a W down here. So if there's 1 up here and 4 in the bottom, that means that there's going to be 3 W's left in the bottom when I'm finished. Now I've got X's, right? They're both in the top. So I'm going to add those exponents. I've got 3 X's here, and here's another X. So really, all my X's, when I put them together, I'm going to have 4 X's. Okay, I've got some Y's in the numerator and Y's in the denominator. So how many Y's are you going to have left, and are they going to be in the numerator or denominator? Right, they're going to be in the numerator, and there's going to be 3 of them because there's 6 on top and 3 on bottom. So when you cancel these 3, it's going to leave 3 on the top. Oh, now I've got Z's, but again, they're both in the denominator. So 3 Z's and 1 more Z all multiplied together means you're going to have 4 Z's being all multiplied together. Now don't forget about these parentheses and that square I haven't dealt with yet. But inside the parentheses, there's nothing left to do. So now to get rid of this last set of parentheses, anything sitting on the parenthesis gets applied to everything inside the parenthesis, as long as it's not adding or subtracting, right? All right, and our rule for that is you multiply. So 4 times 2 is 8. I'm going to do it over here this time. 4 times 2 is 8. 3 times 2 is 6. 3 times 2 is 6. And 4 times 2 is 8. And I know I'm finished because there's no numbers that I can do any math on, like I could over here. That's what I mean by no numbers, right? I just have 1 X, 1 Y, 1 W, 1 Z. No negative exponents, no parentheses, no 0 exponents. So it's completely simplified. Okay. Good luck. Let me know.